Hi, welcome back, Hononegah. Honors, Algebra 2. 7.2 is graphing rational functions. So we're going to start graphing now, and we're going to be doing this for the next few sections here of graphing rational functions. So anytime you have a fractional function is basically what we're talking about here. So when you have a fractional function, such as a direct variation, like y is equal to a over x, the graph of the function where a equals 1 is shown below. So basically what they're graphing is y equals 1 over x below. And you'll notice that there's a horizontal and vertical asymptote. So I need to talk a little bit about that. The vertical asymptote occurs when the denominator of the fraction is 0. So when I'm looking at the denominator of the fraction, x equaling 0 causes a vertical asymptote. The vertical asymptote occurs because you can't divide by 0. And then the horizontal asymptote occurs at y equaling 0 going straight across. So as the numbers continue to get bigger, the fraction continues to get smaller and smaller. So the horizontal asymptote is y is equal to 0. Now, we can do translations and we can move those around. So let's see what that looks like. Let's graph this. You can use a graphing calculator if you want, but I'm just going to talk about the vertical asymptote. So the vertical asymptote is when x equals 0. So I'm going to draw a red line, x equaling 0. Horizontal asymptote. Later we're going to have a bunch of rules about the horizontal asymptote, but for right now, y equals 0. So if I graph this, let's say I plug some points in, like x equaling a half. So you'd get a half, 12, 1, 6, 2, 3, 3, 2, 6, 1. And so this would be the y equals 6 over x. And I'm going to do the same thing on the other side. So like negative 1, negative 6, negative 2, negative 3, 3, negative 2, 6, negative 1. So again, next one. So now y equals, 1 over x. So if I put in 1, I get 1. I'm going to do this one in blue. 1, 1, a half, 2, 2, a half. So you'll notice that it's about the same graph. It's just much closer to the asymptote. So what is happening is this is a vertical stretch by 6. So again, along the asymptotes going in both directions. This is the big slide of the day. So what we just talked about won't be as important as this slide. Here's what I will tell you. If you have this type of rational function, in which you have a fraction plus a k, whatever is being added or subtracted at the end, that is your horizontal asymptote. And then whatever causes the denominator to be 0, that is your vertical asymptote right here. So whatever causes the denominator to be 0 is your vertical asymptote, and whatever is being added or subtracted is your horizontal asymptote. Now, here's how I decide where it's going to be graphed at, is I'm just going to plot one point to the left and one point to the right of any vertical asymptote. So here we go. Vertical asymptote, horizontal asymptote. Those are the first things I should ask. And tomorrow or later when we start getting into this, there's more. There's oblique asymptotes and there's holes or points of discontinuity. But for right now, what causes the denominator to equal 0? And that's when x is negative 2. So on my graph, at x being negative 2 is a vertical asymptote. Horizontal asymptote, whatever's being added or subtracted. So the horizontal asymptote is when x is equal to negative, or y, sorry, is equal to -1. So going across at -1. So there's my vertical and horizontal asymptote. Now, how do I decide how to graph this? I am not going to make you graph a bunch of points. Here's the only thing I would say is pick one number on the either side of the vertical asymptote. So -3, that would be smaller than -2, and -1, that would be bigger than -2. And once you have one point, I can tell you what the rest are going to be. So here we go. Let's plug this in. -3 plus 2 would be -1. And so then -4 divided by -1 is 4, and 4 minus 1 is 3. So this is important for us to look at. -3, +3. What does that tell me? That tells me that it goes along the asymptote this way and along the asymptote that way. So it tells me kind of the quadrant that it's going to be located in. So let's say I plugged in -1 now for x. If I plug -1 in for x, I'm going to get -4 divided by 1. So then I get -5. So if I plug in -1, I get -5. And so that tells me it's going along the asymptotes in the bottom right-hand corner. So just doing one point will tell me exactly where I should graph this along the asymptotes. Next one, I'm going to go a little faster now. Vertical asymptotes, x equals 1. Horizontal asymptotes, y equals 3. So +1 for a vertical asymptote, +3 for a horizontal asymptote. X, y, I only need 1 point on either side of the verticals. 2 would be bigger, 0 would be smaller. So if I plug 2 in, I get +1. If I plug 0 in, I get +5. What does that mean? 2 +1 means it's graphed along the asymptotes here on the lower right. 0, 5 means it's graphed along the asymptotes up here in the upper left. So again, that 1 point tells me where it's going to be graphed along the asymptotes. Next, a 3D printer builds layers of a material to make three-dimensional models. Each deposited layer bonds to the layer below it. The company decides to makes a small display model for engine components of a 3D printer. The printer costs $1,000, and the material for each model is $50. Estimate how many models must be printed for the average cost to be $90. Now, here's what they're saying. So I have $1,000 cost plus 30 for every 50, sorry, for every printer or every one that I print. So this is how much it's costing. Now, if you ever talked about average, you take all of the costs then and divide it by how many you're actually making. And I want that cost to equal 90. Solve. So I'm going to multiply both sides by x. 1,000 plus 50x. Subtract 50 and divide by 40. So x is equal to 1,000 divided by 40. And I get 25. So I need to make 25 models in order for my average cost per model to be $90. So I need to make 25 models. Now, with that being said, what would happen to the average cost the more models you make? So the more, let's say I made 50 models, or let's say I made 60 models, or 100 models. The average cost then would go down because we are dividing the cost of the printer and the cost of the materials. We are dividing that cost up amongst more So what would happen to the average cost the more models you make? The cost would go down. Homework assignment tonight. Now, do not look at the directions, please. Do everything the way I did here in my notes. Is don't do the domain and range. I want you on each and every single one of these, I want you to do the vertical asymptote and the horizontal asymptote. So on each question, do the vertical asymptote and the horizontal. If you have any questions, make sure you talk to your teacher, and good luck.